Okay, so we are going to have y equals to sine x and y equals to sine ax. So the red is the original one, and this is a graph where actually you have like sine, the x is multiplied with a, and the rest remain the same. So I have moved this a equals to 1, a equals to 1 now for me, alright? And then I let it move increase very slowly, and let's see. Now let's start. When a increases, you can see that left and right, the curve is actually squash. Okay, squash, squeeze, okay, stretch. We usually say stretch towards y-axis, and you see that this point doesn't move at all, but the rest of the point they move. All right, this point when y equals when y equals to 0, it doesn't move. And why is that so? Say now we have put it to 2. We move it to 2. So it's closing up to 2. Let's see what happened. So now it's very hard to control it to 2, so I'll make it to 2 now. So you see that at pi, the red curve, okay, has just moved half of the period. However, say this is sine pi. Sine pi is 0, so it stops here. But for sine, now a is 2 will be sine 2x. When you put pi inside, you have to multiply by 2. That's why it moves faster. If you put 1, it becomes 2. If you put 2, it becomes 4. So it goes pretty fast. So it means this is a point when it is at the peak, we should notice that it is pi over 4, because pi over 4 times 2, you get pi over 2. That's where the originally pi over 2 have to be. You can see this or not. So when pi over 2, you need only pi over 4 to arrive at 1. So that's why you can have a trick that is, when it is sine 2x, means within 2 pi, you actually have 2. Originally, there's 1 period of sine, but now you have 2 periods of sine. This is one of the tricks to sketch the sine curve, right? And then let's see what happens when we keep increasing until it's 3. Okay, when it is increased until it's 3, oops, closing in. So we can see, yeah, you can actually expect that is 3. 3, you can see 1 period of curve, 2 period of curve, and 3 period of curve. And when you want to label this point, it's very easy. You just cut into 3 and then you start dividing to 4. So this is 2 pi over 3. This is one set. 1 over 3 means 2 pi divided by 3. 4 pi over 3. 2 pi over 3 times 2, and then you have 2 pi over 3 times 3. That's you get 2 pi. And 2 pi over 3, if you want to label this point, you have pi over 6, because 2 pi over 3, you have to divide by 4, and you do the calculation, you get pi over 6, and so on. And this is even easier. You can have pi over 3, 2 pi over 3, 3 pi over 3, that is pi, 4 pi over 3, and you know this is 5 pi over 3. And then you have 6 pi over 3, that is 2 pi. It is very easy to label using gradient, right?